Good afternoon and welcome to today's webinar, The Future of Making Things in Manufacturing. This webinar today is brought to you by Live Lab Learning, which is a subsidiary of Academic Corp, which is a wholly owned applied software company created to provide world-class training. My name is Trevor Fite and I am very delighted to be here as your moderator today. I've got Jason Miles joining me as well. Now, throughout the presentation, we're going to encourage you to interact with us by typing in questions and comments using the questions pane, and we will be answering those questions at the conclusion of the presentation. In addition, the webinar is being recorded and will be available to you online on our YouTube channel. So if you'll see here, we encourage you to visit livelablearning.com. It is a website that has a number of training classes that are available to you across these different industries here. Next slide, please. We're also hosting an event in Jacksonville and in Savannah, so if you're going to be in those areas on the 16th or 17th, we would love to have you come out and join us. It's a first look event at the new Autodesk 2016 releases. It's really going to be talking about, from the manufacturing side, the complete solution, from CAD to simulation to CAM and managing the data that goes with those different functions inside of manufacturing. But if you're interested in architecture, there's also some great collaboration tools we're going to be talking about in the realm of BIM 360, InfraWorks, and a general overview of the future of technology as it relates to architecture, engineering, and construction. We also have a number of upcoming webinars over the next few weeks. We have one on the 26th about how to leverage the benefits of working with applied software in Autodesk. A webinar on Panzura, which is an IT solution that really can help to kind of refine and streamline the way that you manage data as it goes from one location to another. That's going to be on June 2nd, and on the 16th we've got a turn mill CAM presentation that we're doing. If you're not familiar with the CAM tools provided by Autodesk, they're really coming on strong, not only in the realm of lathe but in milling as well, for multi-axis and 2.5 or 3-axis milling. If you have any questions on those, you can of course contact me. Go back one slide please, Jason. My contact information is down there at the bottom of the screen. I'll be more than happy to answer any questions you have about the details of those webinars, and of course when those links are made available, we'll get those out to you as well. Another thing that's going on this quarter with Autodesk that we're pretty excited about is that as Autodesk is making the transition from maintenance, subscription, and perpetual licenses over to desktop subscription, they're encouraging our client base to get new licenses on 2- and 3-year maintenance subscription terms. They're encouraging cross-grades, and they're also encouraging our clients to consider desktop subscriptions. So you can see here the promotions that are involved. These are rebates that come to you post-purchase. So for one example, on number 1 there, if you purchase a new seat of Product Design Suite Ultimate, there's a $1,500 rebate when you attach a 2- or 3-year maintenance subscription to that license. The other promotions here we can talk more about, of course. If you have any questions about these, you can contact your account advisor or sales@asti.com. And with that, I'm going to hand it off to my intrepid confederate, Jason Miles, an inventor guru that I have the pleasure of working with. Jason, it's all yours.
All right. Thank you very much, Trevor. Well, we're going to start out today with some new things that has been released this year in regards to Inventor. And one key thing that you've probably maybe heard about is the AnyCAD technology. And what this is a class-leading technology that will change the way that you and your customers design. So we know that Inventor provides a fully heterogeneous modeling environment. We know that everyone is working in complex business environment where they are integrating acquisitions and working with vendors and suppliers that may not be on the same CAD systems as the parent company. So what Autodesk has done is they've made it easy to work with this data by enabling direct import and editing of nearly every competitive CAD type without translation. This also makes it extremely easy for new users of Inventor to transition from a legacy CAD system without the need to migrate all of their historical CAD data. So what we'll end up doing is I'm going to go through and talk about another portion of the AnyCAD technology, and then I'm going to go into Inventor and I'm actually going to show you how this works. So the second part is we have the capability to create 3D Inventor parts associative to the source 2D geometry created in AutoCAD. The associative projected geometry can be used to locate Inventor models in an assembly. The 3D part created in Inventor associatively updates when the 2D geometry changes in AutoCAD. So this is a pretty good tool or capability that they've added to Inventor, especially if you have, like I just mentioned, the historical data, and you don't want to recreate the wheel, so why not utilize that data that's already been created, and it just cuts out a lot of steps in creating that 3D solid. So I'm going to switch over here to an Inventor, and I'm going to show you the CAD model that we're going to be dealing with. You'll notice that I am in AutoCAD, and I'm actually going to import that CAD file directly into Inventor. Okay, the first thing that's wanting to know is where am I going to locate this? Now, where it brings it in is actually relevant to where you have it placed in AutoCAD. So I know that a particular, what I call the end view, is located at 0, 0 inside of CAD. So it will actually bring it over in the same location. So down here I knew that's where my 0, 0 was at. So the great thing is, right now I need to go in and perform what is known as translate. This is where I can actually come in and rotate the model if I need to. If I need to relocate the triad, I can do that to maybe another one of these views to help me line it up to my model that I'm creating. So I'm just going to do a few adjustments here. Now another great thing, if you're a big fan of using layers, I also have the capability of turning off and on those layers. So you'll notice, for instance, this one here, I called it Plan View. So I can toggle any of these off or on. So for this one, I'm just going to go ahead and leave it active. And the key thing here, since it is an overlay, I still have to create a sketch. And we're going to notice here, people that's used Inventor before, we would normally project any geometry that we might need to use. Well, we have another tool added up here underneath the Project Geometry drop down. Notice I have Project DWG Geometry. And it brings up a little mini toolbar that allows us to pick individual lines, connected geometry, or we can actually project DWG blocks. So once I have that geometry projected, we just follow our normal procedure of finishing the sketch, and I can go and start the extrusion. Now, one thing that I want to point out is with bringing in a DWG underlay, you can only bring in one file at a time. You can bring it in multiple times, but you can only bring in one DWG. Okay, so I'm finished using this particular orientation of that DWG. So I'm actually going to follow the same process, and I'm going to bring it in once again. That way I can get it lined up to the different planes that I want, So now I'm going to utilize that plan view that I had that had the holes. And let's go ahead and rotate this around. And notice I can relocate this triad here. I can come down here to the solid I've already created. And now I can utilize that underlay here to project cut those holes. So same process, still got to create a sketch. Okay, I'm going to go ahead and just choose that projected geometry. So we'll notice we have our holes. And then lastly, I'm going to bring in the drawing again to get this back section of my part so I can get this cut out here. Okay, once we have this, same thing, we need to go in and perform a translate so we can relocate it. Now the great thing about this is once I have this completed, if anything's going to be changed in AutoCAD, it's automatically going to update my Inventor part. And I'll demonstrate that for you here in just a second. Okay, one more last extrusion here and we'll have it. Okay. So we have our part. I didn't go through and put some of the fillets on there, but you have a good idea here of what we have. So I'm going to go ahead and save this. And I'm going to jump back into AutoCAD. Now, let's just say, for instance, something's changed. So we're going to change some of the, maybe we'll stretch out this section here. And let's say, I'm going to make it 30, add 30 more to it. So it was 107 on the length there. Now we got 137. So now whenever I jump back over to Inventor, you're going to notice, let's go back here. Oh, hold on a second. Let's get frame guide 2. Make sure you have the right file open. So I'm going to do the same thing. Just going to stretch it, maybe 20 more or 30. Okay, we'll save that. Now when I go back to Inventor, I want you to notice something. Notice that we have the lightning icons over here telling us that it needs to be updated. So if I go up there and update it, notice what we have. It's changed here. I can go back and I can work on this at the same time. I can have both open. So let's go back and let's take 10 off of that. Update it again. So notice what we have. Okay. So you'll notice that I talked about that you can also constrain some of these AnyCAD underlay or DWG underlays. You can bring them into a assembly. You also have the option of suppressing the link or breaking the link, just like if you would have like a adaptive part or anything like that. So you can break those links. It also supports constraints and joints whenever constraining to another part inside of your assembly. So it's really, I'm a big fan of this new technology that they brought out, and I hope you guys see it as well. Now, another thing besides the DWG underlay is bringing in the non-native Inventor files. So I want to talk about that just for a second. So now, when we go in and we open, I'm going to import CAD files. And you'll notice I have a SolidWorks part. Now you're going to notice that the dialog box looks a little different. It's a little bit more streamlined, not as many options that we're used to when we're going into, when we're importing a component. So I think this is just a lot easier in deciding what you need to select and not select when importing. Now you'll notice that import type, I have two types. I have a reference model. So what this means is the SolidWorks user, if he made any changes to that part and I was using this part in my assembly, it would automatically update. I wouldn't have to re-import that model. Now if I wanted to make any kind of changes on the Inventor side, this is where I would have to convert the model, just like what we're normally used to. This would bring it in to where I could use like the direct edit or do any kind of manipulation to the model that I need to. So for instance, if I bring it in as a reference model, here's our part. You'll notice that we have a different looking icon over here showing me that this part is referenced. And you notice that it has the SolidWorks part. Okay, and then also you'll notice that if you've imported stuff before, that we have this HTM that just gives us a little bit of information if we had any errors or anything like that. Okay, so moving forward, and just to point out that this works with SolidWorks, CATIA, Pro-E, and some of the other big-time modeling programs that I showed on a previous slide. Now the next thing that I want to talk about, came out last year, and you might not be familiar with it, but this is called Autodesk Nastran. And let me tell you just a little bit about, if you've never heard of it, what Nastran is. So Autodesk Nastran In-CAD is a general purpose finite element analysis, so FEA. It's a tool that's embedded in your CAD system, and it's powered by the Autodesk Nastran solver and offers simulation spanning across multiple analysis types, such as linear and nonlinear stress, dynamics, and heat transfer. This single product is available as a network license and serves multiple CAD platforms, providing a consistent user experience and eliminating the need for multiple single platform simulation technologies. And it delivers high-end simulation technology in a CAD embedded workflow, so you can, test your products, run different simulations on it as needed during your design process. By offering this CAD embedded benefits, what I mean by that is that it's not going to have to launch a separate software. This is actually, and I'm going to show you this as well, it's actually going to, especially in Inventor, it's going to add another tab to your ribbon. So you that are familiar with performing stress analysis in Inventor, you would go to the Environments tab. Stress analysis is going to work the same way. So by offering this workflow, the Nastran In-CAD streamlines processes, so helping you to maintain your productivity and eliminate compatibility issues while equipping you with an industry-recognized professional level FEA platform. So Nastran delivers a powerful FEA technology while keeping the familiarity, ease of use, integration, and associativity of your existing CAD system. Now, a few of the basic analysis capabilities you can see here. We got such things as buckling. We can deal with linear steady state heat transfer, thermal stress, and a few others that you notice here, just on the basic capabilities. But also with Nastran, we actually have some advanced analysis capabilities, such as nonlinear statics, nonlinear steady state heat transfer, advanced nonlinear and hyper elastic materials, and then also an automated impact analysis as well. So let's jump back over to Inventor, and what we're going to be dealing with is this manifold. Okay, you'll notice in Inventor how it's added this tab, and to get to this tab, it's just the normal workflow here. You'll notice that I have a Autodesk Nastran In-CAD in my Environments tab. Now, for this particular problem that I was trying to solve with this exhaust manifold, I was ended up running a nonlinear steady state heat transfer and thermal stress. Okay, this model is made up of steel, and the goal for me was to get a temperature distribution based on the applied thermal loading from the nonlinear steady state heat transfer analysis, and then use that temperature distribution to determine the effects on the part due to thermal expansion. Okay, so I've already ran these two analysis, but I kind of want to walk through and show you the ease of use on how it is to set it up, especially if you've never used simulation before. So if you like working in the model browser over here to the left, or some people might call it the model tree, you can work going from top to bottom, setting everything up, or in the ribbon, we can work from left to right. Okay, so the first thing that we have here, notice we have materials. Okay, and for this particular one, I have added this steel 4130. So what I like about this, since it's embedded into Inventor, notice that I have the option to go in here, and we're familiar with the Autodesk Material Library and the Inventor Material Library. So I can come through here and select a material from either one of these libraries. Also, if the material that you're looking for is not in that library, well, guess what? We can actually go through and we can create a new material. So you'll notice all of the different properties that we can fill out. So once we have that set up, I want you to notice what we have next. So going from left to right, my physical property, that would just be where I would come in and set the type, whether it's going to be solid, shell, or line elements, and then I would just choose that material, whether if it was from my library or one that I created. Okay, and then notice here, since I went in and was messing around with the physical property, it just wants me to remesh. So we'll let it finish its process here. The next thing that we'll end up doing, continuing from left to right, is I'd want to set up some some loads or apply some loads. Okay, and you're going to notice that I've set up I got 3 different loads here. So I got a nonlinear steady state heat transfer load, and you'll notice that I selected the internal portions of my exhaust tubes here, and I set the type as a heat flux, giving it a specific magnitude here for the load definition. Then the next load that I ended up applying was a convection load. And then whenever this dialog box comes up, we'll see some of the input that I applied to this model. So notice type is convection. I gave it a ambient temperature of 70 degrees, and then also a convection coefficient. Now, once I did that, I just gave it an initial temperature on what the environment was around, and I just set that as 70 as well. So once we have that, we can run the model, and I want to show you what we get whenever this analysis is ran. And I do like this plot dialog box here because we can go through and I can display it, what it's going to look like, and you can see I have my max and min. So the max I'm getting is 682.2, and then maybe I want to control some of these visibility options. Maybe I don't want to see all those loads or the element edges, just to clean it up a little bit. And then you can go through and see if this is coming out to what you intended to see with this model, and then you can make any kind of changes that you need to on the fly. Since we're still in Inventor, you can go back and make any changes. Okay, and then we want to take this a step further. So I want to look at the thermal stress. So I'm just going to set this as the active analysis. Okay, notice thermal stress. Went through and took out certain things, a couple loads here, and I just gave it a temperature load. And then I added some constraints here on the holes, and you'll note that I have it's a sliding constraint with the pink little arrows showing. So I got a structural constraint and a sliding surfaces. Okay. So the structural constraints for all the holes for the bolts, and then sliding on this surface and this surface. And I'm going to go and we're going to actually look at the von Mises. And you'll notice here on our thermal stress, you'll see some of the discoloration in regards to our table over here to the left. And you also have different other options, just like such as you can animate it. And you can also do other things, like if you want to probe on certain areas. And then you also have the option of, plotting out your results. So you'll notice down here at the bottom that we have the capability of, we have some plot templates where we can plot out deformed, contour, contour on deformed, or criterion contour. So we can get different kind of reports and data as needed. Okay, so hopefully you can see that this has added quite a few more capabilities than just your standard Inventor FEA, and that this can also, Nastran also works not only in Inventor, but also in SolidWorks as well. Okay, so let's switch back to our PowerPoint here, and let's talk about what's some new things in Vault 2016. So you'll notice that we got CAD integrations. That's where the Vault supports AnyCAD and DWG underlays. And also the copy design. So we got a brand new interface that I'm going to show you. We got a unified lifecycle definition and some BOM enhancements. So for the lifecycle definition, you can manage item release the same as files, and then you have a little bit more flexibility for raw materials in workflows. But I want to really focus on the first two, the CAD integration and copy design. So just as you noticed in Inventor, or even placing third-party data into Inventor, we saw that we have the reference model option. So this option, you bypass translation entirely. It places the native file into the design, and Inventor creates and maintains a reference to the original design. But when paired with Vault 2016, you can then check in the assembly carrying over the native files, not translated versions. Then, when you receive updated design files, only thing you have to do is simply update the files in Vault and open the top-level assembly in Inventor, and any changes to the model can be updated in a single click, all while preserving the work you've already completed. Now, within Vault, you can perform many of the same actions on imported CAD data as you can within Inventor files or with Inventor files. File properties can be edited just like any other file managed inside Vault. You can also designate categories, apply lifecycle controls, and assign items to imported CAD files, so they can be easily managed alongside all your other product data. So in addition to the third-party reference support, Inventor 2016 also introduces support for AutoCAD underlays, as I mentioned. Vault 2016 provides reference support, allowing users to add, check in, and check out drawing files used in Inventor. Now, the new copy design interface, you're going to notice that it looks a lot different. So the main grid displays current configuration settings, including action applied to the original file, the new file name, and new copy design specific values like component ID and component quantity. So these two values help you identify individual reference information. Okay, in addition to the main grid, there are panels to help you see alternate views of the data being copied, find specific source components, change the part number settings, or get an overview of the results. In regards to some of the flexible configuration, so to improve the efficiency of copy processes, you can now include multiple data sets in a single operation. Multiple assemblies and files can be added and independently configured. You can also specify whether you would like to copy all the files or just the top-level nodes, and whether you want to include library files or non-CAD files in the copy operation. We also have more control over how individual files are handled during the copy operation. You can manually specify whether files will be copied, reused, or removed, and you can also replace files during the copy operation, which you can now do using files that will be created as part of the current copy design procedure. So to provide a clear picture of all the configuration actions that will be carried out, an action panel has been created on the side of the interface, which helps you identify issues early, such as files unintentionally being edited. The folder panel provides an intuitive view for renaming new folders, moving copy files to new folders, or initiating copy operations by dragging and dropping files or entire folders to the new design. So productivity enhancements. So per customer request coming from you guys, automated file numbering is built directly into the copy design process, removing the need to perform, a secondary step after the copy completes. In addition, you can also specify category and property settings for files as you set up the copy. In addition, you can also specify category and property settings for files as you set up the copy. So copy design runs from the Vault server now, driving faster performance. So in previous releases, copy design was a part of the Vault client and files had to be downloaded for copy, which was time consuming. So now copy design gets the files directly from the server, eliminating much of the download time and optimizing copy design performance. So I hope that I've showed you a few things today that you can utilize in your current workflow. And if you are getting ready to upgrade to Vault 2016, you can see that there's quite a few enhancements that can possibly help you in your data management. And with that being said, I'd like to turn it back over to Trevor.
Okay, can you hear me now, Jason?
Yes, sir.
Okay, sorry about that. I did have a few questions that had come across during the presentation, so we'll start with those. But if you have any other questions, now is the time to get those out there. You've got a pane on your GoToMeeting dialog there where you can type in a question, and we'll be happy to try to address those questions and answer them. But I'll go ahead and start with the ones that we got during the call. Good question. Does associativity with AutoCAD into Inventor need to be to and from AutoCAD 2016 as opposed to the previous versions of AutoCAD and or Mechanical?
Okay, that's a good question. So yes, you can bring historical CAD data in. So if I had like a 2014, I could bring that in. So the answer to that is it is backwards compatibility in that respect.
So just to confirm for layman's terms, Jason, if I'm using Inventor 2016 and someone sends me a 2010 DWG file, I can bring that in and have the associativity, correct?
That is correct.
Okay. Hopefully that answers your question, Mike. If not, please elaborate and we'll be happy to take care of that as well. Another question that came up would be, I think, when you were talking about the underlay, wouldn't you want to union the end view of the AutoCAD file to allow the fillets to associate with the Inventor model?
Yes, you would. You would. I was looking at that whenever I was bringing it over, but yes, that is correct, and that is possible. So if you make that modification to the fillet and AutoCAD, you would definitely want that to happen in Inventor.
Okay. Got a couple more questions coming through. Why did the edge of the Inventor drawing become a V when you lengthened the .dwg?
That is in regards to the location of the XY. I would just have to go in there and modify that in my Inventor draw, or the Inventor model.
Okay. Another question on Vault Professional. Does it work with SolidWorks? I would like to answer that one myself, but I'd like Jason to elaborate. The answer is yes. The AnyCAD technology that is now in Vault, and Jason and I talked about this last night, allows you to bring in SolidWorks assemblies, integrate them into the Vault environment, and have them live in harmony, so to speak, with Inventor content, AutoCAD content, or non-CAD content. And Jason, please elaborate on that.
Right. So just like what Trevor said, so any file types, and there's also the capability, and it was actually with 2015 as well, being able to upload SolidWorks files into the Vault. But they've made it easier in the 2016 without a separate add-in where it's already built in, allowing that to happen.
Typically, we would have to request a plug-in from Autodesk directly for SolidWorks, but now not only have they made SolidWorks natively a part of Vault Professional, but the same is true for Creo, for NX files, CATIA V4, and V5. So that functionality as far as the integration of SolidWorks and other file format content with Vault Professional is just native out of the box with Vault Pro 2016. Any other questions? Okay, do assemblies in SolidWorks with constraints, will they stay in Inventor?
Yes. Yes, they will. So I guess they're looking at bringing in an assembly and then building their Inventor new designs around that. So that's where it was talking about that it would keep those, and then you have the capability of using, the regular constraints and also the joint constraints to fully lock it down.
Okay. And I see I think that's all the questions that we have at this time. I'll have another call out one more time here for more questions, same and backwards. So that's a follow-up on the last question, Jason. If you bring in those assemblies from SolidWorks, will the constraints stay in Inventor? And if you do edits in Inventor, I'm imagining, would those work backwards to the SolidWorks user?
No, it doesn't. Any changes that need to be made, if they're referencing that model, the changes need to be made in SolidWorks, okay, to update it in Inventor. Now, if you truly import that model and you make any changes to that SolidWorks file, that's not going to translate back to SolidWorks because you broke that link by importing and not referencing that model. Does that answer your question?
Yes, that did answer the question. Now, we have some other things that we're working on as well that I think for those of you who are working with other file formats could find very interesting, but they weren't a part of the agenda for this particular webinar. So I'll take some of these questions, especially those related to SolidWorks, offline, and we'll be meeting with some of these companies that have representatives here today to address those questions in more detail when we talk again. Any additional questions? Okay. I would highly recommend that you subscribe to our YouTube channel. If you do a search on YouTube for Live Lab Learning, we record every one of these webinars and put them up there so that you can go back, view them again, share them with other people who may have missed the webinars. And we would highly recommend that you subscribe because that's going to be a one-stop shop to see a lot of information not only on Inventor but on Vault, AutoCAD Electrical, and other products. And of course, I wouldn't be a good host if I didn't say thank you so much for joining us. Thank you so much for joining us today. We have a number of things that you can look for on Facebook. You can find Live Lab Learning out there as well. And you can also visit the website livelablearning.com altogether for a complete schedule of upcoming training and informational webinars, tidbits, and software updates. So we hope that you found this webinar informative and helpful for your business. And we look forward to joining you on our next webinar, which I believe is on May 26th. So you'll get an email about that prior. If you have any additional questions, don't hesitate to contact me with any of those questions. My email was presented earlier in the presentation. And have a great afternoon, everybody.